In this video, we will be solving equations involving indices by reducing it to a quadratic equation. First, let's work on this example. We can start by looking for the common index form as before. Can you identify the common index form? Note that the index forms have a common base, 2, but the indices are different. What can we do? Well, let's try expressing 2 to the power of 2x in another form to help us identify the common index form. We can express 2 to the power of 2x as a product of index forms, which is 2 to the power of x times 2 to the power of x. Notice that we have two identical index forms, 2 to the power of x. So, 2 to the power of 2x is the same as 2 to the power of x squared. Let's replace 2 to the power of 2x as 2 to the power of x squared. Now, can you see that 2 to the power of x is the common index form? Again, we can substitute the common index form 2 to the power of x as y. Now, let's observe the equation. Does it look familiar? Yes, this is a quadratic equation. We have reduced it to a quadratic equation by substitution. We can solve this equation to find the value of y, which is y equals 2 or y equals 4. Now, are we done? No! Always remember that we are solving for x and not y. So, let's replace y with 2 to the power of x. We write 2 as 2 to the power of 1 and 4 as 2 squared. Again, bases are the same now, and we can compare the indices to get x equals 1 or x equals 2. Next, let's try one more example. Again, are you able to identify the common index form? It's alright if you're unsure. Let's find out together. We know we can express 9 to the power of x in another form to help us identify the common index form. First, we express 9 as 3 times 3 and simplify. Again, we have two identical index forms, in this case, 3 to the power of x. So, 9 to the power of x is the same as 3 to the power of x squared. Let's replace 9 to the power of x as 3 to the power of x squared. Now, you should be able to see that 3 to the power of x is the common index form. What's next? Like before, we substitute the common index form 3 to the power of x as y. Again, we reduced it to a quadratic equation. Next, we proceed to solve for y to get y equals 3 or negative 8. Once again, we still need to solve for x. So let's replace y with 3 to the power of x and write 3 as 3 to the power of 1. Now, the bases are the same, which is 3. Thus, we can compare the indices to get x equals 1. But how about the solution negative 8? Well, we need to reject this solution as 3 to the power of x must be positive. In general, when solving equations involving indices by reducing it to a quadratic equation, first, we identify the common index form, then we reduce it to a quadratic equation by substitution and solve for the substitute variable before replacing it back with the common index form. Next, We express the bases as a product of prime factors and compare the indices to find the unknown.